Hi guys, good morning. Welcome back to the next video. Although, usually you would see that the explanation of easy problem never comes on our channel for the daily problems. But this question, oh God! Although to solve this question, you can solve it in 3 lines in under 1 minute. But the way to go from brute force to better to actually optimal, it's insane. It can be a high chance that it can be asked in an interview, and the interview might ask you, okay, give me the most optimal solution of this problem. And to understand that part is actually the tricky part. Cool. No worries, we will actually go into this problem very quickly. It just says that we are having a sequence of numbers is called an arithmetic progression called as an AP if the difference between any two consecutive numbers is the same. Is basically, if you know, AP is nothing but a sequence of number in which the difference between two consecutive numbers is the same. Cool. So for sure, if there is a standard formula, although if you don't know the formula itself, you can simply make an AP as a plus d, a plus 2d, a plus 3d, up to so on, a plus n minus 1d. Why such that? Because for sure you will see that the difference between two elements, it's d. This difference between all the consecutive elements should be same. It should be same. Here we make it as d. That's the reason. Firstly, for sure you would easily see that this sequence will be increasing or decreasing or same, which means it can be non-increasing, non-decreasing, or it can be same, right? Like increasing, decreasing, or same. Thus, you can easily see that the difference between exactly d, right? Okay, one thing for sure. And also, if you want, see, please, if you want to get better at maths, please, at a question itself, just understand the formulas. There's a high chance that although in this problem this formula is not used and you can easily make this formula, but I highly recommend, please, it's a basic formula of arithmetic progression, which is nth term of an arithmetic progression is a plus n minus 1d. It is the nth term of an arithmetic progression, and the first term we name it as a, which is the a, and it is the nth term. So for sure, by now you know, okay, AP looks something like this: a plus d, a plus 2d, and it can be increasing, or it can be decreasing, or it can be same, right? So that the d will remain same. And also please remember that arithmetic, and it is not used in the problem, although you can also derive this from here also, but still I'll highly recommend to remember this fact that nth term of an AP is a plus n minus 1d. Cool. Now if we just go back and the example, then we saw, okay, we want to know if this sequence is an AP or not, and we know for sure that the sequence will for sure be increasing or decreasing, right? So we are only concerned about if this sequence is an AP or not. So first thing which comes in our mind is, okay, just to sort this sequence, the sequence will become something like this. Now the difference between consecutive elements should be 2 for sure, which means it should be same, which means the difference what is here, it should be exactly the same what is here, and so on and so forth. So I just sorted this sequence out. It became 1 3 5. The difference is 2. Okay, it's an AP. I can easily say that part. Why? Because we saw that how an AP is made. Now the same concept I will apply this here. 1 2 4. I'll check the difference. Okay, it's 1. It should also be 1, but it is 2. Okay, it's not an AP because the difference should be same. It's a prime condition of the AP. Cool. We have the constraints pretty less. We know, okay, we can simply sort this down. We can simply sort this sequence. So whatsoever sequence we have, we can simply sort that down. 1 3 5 7 and 9. Find the difference 2, find the difference 2, find the difference 2, find the difference 2. Simply say, okay, the difference between all the elements is the same, as for sure it will be an AP. As simple as that. So simply, you know, one part, just to sort it down, O of n log n, and then after, when it is sorted, just see, okay, just check if the difference between consecutive elements, just start from I equal to 1 and do a of I minus a of I minus 1, which means a of I minus a of I minus 1. It is the difference. If the difference is the same for all the i's starting from I equal to 1 to I equal to n minus 1, you can simply say that it's an AP. If it is not, then in the mid also you can return a false. So it is the one way, which is the brute force way, which comes directly to our mind. It's the reason that it is marked as an easy problem, because it can struck instantly, and you will solve this by a brute force in O of n log n. And You're not using any extra space. So it's the reason it is over fun. But now I ask you, optimize it, make it better, just better. So what you will say, okay, Aryan, ultimately what I was doing is, I know, okay, it is a sequence. I know that it is my input sequence 13957. I also know that the output sequence would look something like 13579, right? So how about, okay, I can iterate on this particular array and I would know what is the minimum element, because to generate this AP, what you need? To generate this AP, what you need? You need an A and an D, right? Okay, Aryan, to get an A, to get a D, what I can do is, and I have some elements, random elements. I won't know what is A plus D, what is A plus 2D, what is A plus CD. I don't know what are the mid elements. But for sure, I know one thing. What is the smallest element and what is the largest element? It is one thing I know for sure. I don't know the mid elements because mid elements can be in any order. But the largest element and the smallest element in this array, it can be here also. It can be here also. It can be like, okay, 5, 7, 9, 1, 3. So the largest element will always represent A plus n minus 1D, and the smallest element will always represent A. I know n for sure. 1, 2, 3, 4, 5. N is 5. A I know because of my smallest element. Now I know the largest element is A plus n minus 1D. Largest element is 9. I know A. I know n, which is 3. N minus 1 is 2. So I can easily find a D from here. So ultimately my aim was to find an A and D, to generate this sequence itself. I can know by just getting the minimum and the maximum element. So for sure, what I will try to do is I will try to make my own sequence, and to make the sequence itself, I just need an A and a D. I got a A for sure. To get a D, I just got the largest, and to get a A, simply iterate on this particular array, find the minimum value, find the maximum value. Minimum value is 1, maximum value is 9. Minimum value represents A, maximum value represents the last element of the AP, which is nothing but A plus n minus 1D. We know the A. I will replace A here. I know the n, which is the number of elements in this entire sequence. It is 5. 1, 2, 3, 4, 5. So 5 minus 1 is 4. So basically D will say 9 minus 1 by 4, which is 8 by 4, which is 2. As you will easily see, the D was actually 2 also. So I know the D, I know the D, I know the A. What I will try to do is, I know, okay, the first element of this sequence will be A. The second element will be A plus D. The next element will be A plus 2D. Next will be A plus 3D. Next will be A plus 4D. So I know, okay, one element in this sequence should be A. Okay, cool. Aryan, what I will do is, I know, okay, the first element, it should be A, which means 1. So 1 should be present in my this particular input. Because see, now I just know what elements I need to expect. I need to expect A. I need to expect 1, 3, 5, 7 and 9. And how I can make this? By simply using this A and D. But now I need to check if these elements are actually present in my input sequence or not. So what I can simply use, I can simply use a hash set, unordered map, unordered set, anything like that. With that help, what I will do is I will just check, okay, is 1 present in my input? Yeah, 1 is present. How to know that? By simply using an unordered set or an unordered map. Anything you can use to just know, okay, if 1 is present, cool, yeah, 1 is present. Is 3 present? Yeah, 3 present. Is 5 present? Yeah, 5 present. Is 7 present? Yeah, it is present. Is 9? Yeah, 9 is also present. Okay, it is completed. For sure, my input was actually an AP. So basically, I did not need to sort this entire thing out. I just generated this particular entire thing by myself. Or you can simply say, okay, the first element, it should be A, which means just go and search for 1. Next element should be A plus D, just go and search for 3. Next element should be A plus 2D, just go and search for 5. Next element should be, just go and search for 7, which is A plus 3D. By so on, you will just go and search it in this. If it is present, just remove it, or simply do anything you want, or simply use an ordered map, or simply reduce the frequency and stuff. But simply go and check if it is in your input. If it is, good. If it is not, then simply return a false. By this, you know one thing for sure, you did not need to sort it. You just generated your own sequence by using your A and D. And how you found your A and D? By simply using your minimum and the maximum element. By this, your time will be nothing but O of n and space also O of n, because you are using an unordered map or an unordered set. Now comes the most interesting part. I again ask you, optimize it. How will you do that part? Simple as that. Now see, you optimize it. Now you know, okay, you can't use an unordered map or an unordered set to actually compare with your original sequence. So for sure, I need to think of something else. I know it is my sequence. I know my expected sequence would do something like this. So why not? See, I was just confused. Okay, one was at its right location. I can see when I say, okay, I can't use extra space, so I will try to optimize or something that maybe I don't want to store the correct location of that particular element, which means for 1, for 3, for 9, I don't want to know the exact location. I just want, okay, at that point, if it is not at the right location, I will just push that element to the right location, which means if I just go on to the sequence, I know for sure I'll simply use the concept I learned here by simply generating the actual sequence I need, right? I know 1, I know the minimum, I know the A is 1, I know the D is 2, right? I'll try to generate the sequence itself. 1 is at its right location, 3 is at its right location, which means the first element will be 1, next element will be 3, next element should have been 7, but it is here, sorry, next element should have been 5, but it is here 9. So now earlier my concern was next element should have been 5. So I was looking at, okay, is 5 present in my array? Now for that I need to store the occurrence, the frequency of 5, or basically the occurrence of 5, right? Rather just, okay, 9 is present. I will ask, hey, if 9 is present here, what can be the location of 9? So that I will just push that 9 to its correct location. So that later when I will go on to 9, I will just say, okay, hey 9, oh, you are here. So basically what I will try to do is, I know 9. Now, I can't use extra time. I just want, and I also can't use extra space. I'm simply iterating. I want, okay, at this iteration itself, 9 was not something good. I don't want it. I don't want this 9. But what I can infer from 9 is simply just, okay, what is the actual expected index it should go to? Expected index it should go to is 4. How we know that? Simply because we know if I have a sequence as A plus D, A plus 2D, A plus 3D, and so on and so forth, if the indexes are 0, 1, 2, 3, 4, simply know okay, the element at the ith index, it should be A plus ID. As simple as that, because see, it is A plus n minus 1D, right? For the index I as n minus 1, your element is A plus n minus 1. So you can simply infer, okay, the element at that index, it should be A plus ID. So if the 9 is present here, I for sure know one thing, okay, what is the expected position of 9? 9 is here. If I just do a plus ID, A is already I know because of the minimum value. I need to find out. D I already know. Why? Because initially, because of the above thing, because of the minimum maximum element, I found out my A and D. Okay, my A and D is found. A and D I have known. I will find the I. I is found out to be 4, which means it will just say me one thing. Hey, 9 expected location is actually index 4, not index 2. So please do one thing. Make this 9 go at its actual location. Okay, 9 will go at its actual location. But what about this actual, what was actually at index 4? It will just come at a place of 9. As simple as that. But now you will again see, okay, 7 came at this location, 9 went at its right location, but still the expected value was not the 7. It was actually 5. Still, until and unless the actual expected value comes at this location, I will just keep on repeating the process, which means I will just again ask, hey, A plus ID, which means 7 is equals to 1 plus I into D. 7 I is equals to 7 minus 1 is 6, 6 upon 2, which is 3. Expected location of this number 7 is index 3. So please 7, you should go to your index. So it will go here and the 5 will come here. You saw 5 came back to its location and 7 is at its location. So it can be again a possibility that this element is not at its right location, but still we saw, okay, now it is at its right location, but because of this index right here, my 9 went on to its right location, my 7 went on to its right location. Now ultimately my 5 also came on its right location. So you saw at every swap, at every loop occurrence, my one element is going on its right location. So basically as soon as you go on to the 5, now my main array is 1 3 5 7 9. Now I was at 5, okay, it is at its right location. Now as soon as I go on to the next element, it is also at its right location, because of this 5, this 7 came at its right location. That's the reason. That is the reason that you will at max go on to every element twice. How twice? Aryan, you saw, right? I went on to 7 once I was here, which means once my 7 came in here, then I went on to this 7 and put that 7 to its actual occurrence, which is here, and then when I iterated on the next element, so again I occurred it, but now it is at its right location. So basically when we touch an element, either it is actually okay, it's at its good location, or at max we will actually place it to its right location, and next time when I will again occur it would have been at its right location. So basically at max I am touching every element twice. That's it. Because see, in one occurrence it will just go on to its right location, and in the next occurrence I will just go and skip that, because ultimately I will know, okay, it is this element, it should have been a plus id only, and it is a plus id also, so I can just move on to the next element, and so on. I will just keep on going. As you saw, what will happen, I initially started with this, I was at 1, and I should be having a plus id, which is 1 only, which is 1 plus I as a 0, 1 plus 0 into 2, it should be 1 only. Okay, cool. Skip, move on to the next element. It should be a plus I into d, it should be 3. Yeah, it is there. Okay, skip. Now I am at 9. It should be actually 9. It should be actually a plus id, a plus I is 2, d is 2. So it should have been 5, but 5 is not there. So for sure, it is not at its right location. So cool, no worries. Just see what is the expected index for this number. We saw it is actually a 4. So I will just move this 9 to its actual location, and now it will come. Again, I will just say, okay, is it equal to the number which is expected? No, it is not. So again, go and find its index, which is its expected one, which is 7 is equals to 1 plus I into 2. I is actually a 3. Plus, please move this number to its expected location. So I will just move this number to its expected location by simply doing a simple swap, and then again I will just go and check, okay, if this number is actually the expected one. Yeah, it is. Cool, no worries, just move on. I will just move on. If this number is expected, yeah, 1 plus I is actually a 1 0 1 2 3 3 into 2. Yeah, it is a number which is expected. Cool, no worries, move on to next. If it is expected, yeah, 1 plus 4 into 2, which is 9. Yeah, it is expected. Cool, no worries. Oh, my array is finished. Yeah, it was actually a correct sequence, and that is how by simply not using an ANOD map, by simply judging, okay, what is the expected location it can be, I will just go on to that location and simply finding the answer. Let's quickly, and you saw, right, the time is nothing but O of n, because you are touching every element just twice. Space is O of 1 because you are not using any extra space at all. Right, cool. Let's quickly see the code. Firstly, as very sure I showed you that I need to find my a and d. To find my a and d, I need the T0, which means first element and the last element. First element is a, last element is a plus n minus 1d. So last element is maximum element, first element is the minimum element. Minimum element, I will get the a. for the last element, which is the maximum element, I know the A, I know the N, I will simply go and get the D. So I will just go and firstly find the minimum and the maximum value of this entire sequence. Because of this minimum and maximum value, I know the minimum value is nothing but the A, and the maximum value, because of the maximum value, I can easily find the D. So firstly, a small check that, okay, my A plus N minus 1D, which is the maximum value, it should be the maximum value. So for sure, if it is, let's say the max value, let's say it is a MV, so MV minus A upon N minus 1, it should be a D. So for sure that MV minus A, which is the max value minus A, it should be divisible by N minus 1, only then my D can actually come in. So that's the reason I just do a simple sanity check that, okay, max value minus A, it should be divisible by N minus 1, only then it is actually a number, or else I will simply return a false, right? Now if it is divisible, I simply go and find a D. Now I simply go on and start iterating my entire array. It's a simple while loop, because you saw that it can get a simple, if it was 9, 5 and 7, it was at this index for 3 times when the 9 was being swapped, when the 7 was being swapped, and now ultimately when the 5 was here. So ultimately I am using a while loop. You can also use a for loop, it's up to you. Now simply I do check, okay, if that number which is actually present at that index, it's actually the expected value which I had, which is A plus ID. Minimum value is nothing but a A, so it is actually equal to A plus ID. If it is, then do simply go on to the next element. But if it is not, I will simply go and check. If this is not, go and try to find its expected location. So what I will do is, I will try to go and find, here it was 9, 5 and 7. I need to find the expected location of my A plus ID, right? A plus ID. I know A, I know D. So I need to go and find the expected location of what? Of this particular element, which is A of I. Here it is A of I. So I need to find the A of I expected location. I know A, it is 1. I know D, it is 2. So basically A of I minus minimum value upon 2, which is D, it should be equal to I. But for that, again, I have to do a sanity check that, okay, it should be actually divisible by 2. So basically A of I minus minimum value, it should be divisible by my D. So I do a simple sanity check again. A of I minus minimum value mod D, it should, if it is not equal to 0, which means it is not divisible. So it is a simple sanity check. If it is not, I need to return a false. If it is, I will simply go and find the possible location of that particular A of I by simply doing a of I minus min value, which is A upon D. So it will simply get the possible index of that particular element A of I, and by this I know, okay, it is a possible index. And I also know one thing, that my earlier part is entirely correct. So this particular element, its occurrence should be beyond this range, which means beyond my location I, it should be there. If I need to swap that, so because earlier part I know it is already sorted, it is already exactly an AP. So this occurrence, its occurrence, it should be in the later part, right? So I just had this simple check, okay, this possible location, if it is less than I, you are screwed up. It is not an AP. And also, what if the possible location value is itself the same as that of A of I, which means if I would have said, okay, its actual location is at the index 4, but at index 4 also again I have a 9, then you will see that it will stuck into an infinite loop. It will go 9 here, it will again 9 come here, 9 will go here, 9 will come here, 9 will go here, 9 will come here. So it will go keep on going in an infinite loop. That's the reason I have to put and check that, okay, if the possible index value and the actual index value, if the both are same, please, you are screwed up, please return a false. Else, if it is not the case, then simply do a swap, because I know by swapping the value, I am putting my 9 at its expected location, which is the possible location. By this, it will simply go and at max, in the worst case, it will simply go 2 times at every element. Every element is touched 2 times at max, and thus the complexity of this loop is nothing but O of n, and simply I can return a true, because simply this loop is completed, which means I have gone on to every element. I know this video has gone up pretty long, but that's the reason I have to make this easy questions video, because I usually never make it for sure. I usually never ever make it because easy questions are just simply done. But yeah, his question was actually amazing. It's an interview problem, a math being applied, optimization being done at another level. Thinking of that part is very tricky. That is the reason I just tried to make it. I hope that you guys liked it. See you in the next video.